Hello, everybody. For today, I'm going to go over the homework questions from Monday and Tuesday. And also, I'm going to give you guys some examples in which how the synthetic division can be applied to solve polynomials. And at the end, I'm giving you an exit ticket for you guys to write down the answer in the chat on Zoom. Today, you guys have no homework assignment from me over the weekend. Just enjoy your Thanksgiving weekend. And hopefully I'll get to see you guys on Monday. So after this participation grade, in which what I'm going to put in for today, that's it. And hopefully we can move on to the lessons on polynomials for synthetic divisions and the how to apply to solve for the zeros, as well as remainder theorem. And anyways, let's get started. Oh, sorry. Okay, so first, this question here, we have for each of the following cubic equations, one root is given. This is the homework from Monday. Determine the other roots of each cubic. So here, once again, we are using I think you can use long division to solve for it, but this is x is equal to -2. Determine the other roots of each cubic. So one of the roots is given as -2. So that means that if I'm converting into a factor form, I have to put it as x plus 2. And then x cubed plus 4x squared plus 7x plus 6 is right there. X squared here, and then plus 2x squared. Subtract these two. You get 2x squared, bring down the plus 7x, and then plus 2x. Then we multiply those two together, and you get 2x squared plus 4x. Subtract these two. Then this changes to a minus sign. Then this cancels out and becomes plus 3x. Bring down the plus 6. This becomes plus 3. Okay, so now what we have here is the remainder to be 0. If you multiply the 3x here, 3x, and then 3 times 2 becomes 3x plus 6. And when you subtract these two accordingly, you get a remainder of 0 here. Now what that means for us is that this becomes one of the roots is at -2, but x squared plus 2x plus 3, well, unfortunately, that is not factorable. And so if you were to use, let's say, the quadratic formula, that is still not going to give you the right answers, but because we're asked to determine the other roots of each cubic, we want to look for what we call two imaginary solutions. -2 plus and minus the square root of b squared minus 4 times a times c all over 2a. Now, why am I using quadratic formula? Because it's not factorable. And you will see that once you do the quadratic formula, you get a question, that's 2i squared of 2 over 2, and you get a question where you get two imaginary solutions and then one real solution. Hence, if you add the number of solutions, technically, that's still 3 in total, and because the fundamental theorem of algebra tells us that the number of roots has to match with the number of the degree of the polynomial here, which is 3. Therefore, I know that these are the number of roots here. So even though these are two imaginary solutions, not real, I would still like for you to solve for it once the situation arises. All right, so for the next question, we have 2x cubed plus 9x squared plus 3x minus 4 divided by x plus 4, of course, because you need to put an opposite sign. 2x squared, subtract them. How many times can x fit in x squared? Plus x times, of course. And then you subtract these guys, you get -x, bring down the minus 4, and that becomes -1. So this right here, 2x squared plus x minus 1 as our quotient, well, that is certainly factorable with 2x and x, plus 1 and minus 1. So if I'm looking for the other roots, x is 1/2, x is -1, so we have 3 roots at -4, at +1/2, and at -1. All right, these two questions. Determine using the long division, right, yes or no. So is x equals 4 a root of this equation? So once again, I'm going to write this. And what I'm going to do is I'm going to write how many times can x fit in x cubed, so x squared times. And then what you're going to do is you're going to subtract, again, this is minus 2x. And then when you subtract these, make sure you flip the sign, 17x plus 1, so plus 17. So I can clearly tell that if I multiply the 4 with the 17, I get 68. Well, that's 17x. But I am certainly going to get a remainder of 69, I believe. So therefore, we know that, well, the reason why we get 69 is because if you were to subtract this 17x from both sides and subtract negative 68, well, that makes it a positive. So 1 plus 68 becomes 69 here. Sorry, I keep on running out of spaces down here, but I'll try to show it on the part C. So the remainder is 69, therefore, I mean, as long as it's not equal to 0, therefore it's not a factor. It is not a root. All right, so for the next question, is x equals negative 1 a root of this equation, x cubed plus 6x squared plus 3x minus 5. And we're going to divide by x plus 1 here. And so what happens is that this becomes x squared, and this is x cubed here, and plus x squared. You would subtract these two, 5x squared, bring down the plus 3x, plus 5x, 5x squared, plus 5x. Subtract these two, and you get negative 2x, and bring down the minus 5 here. And so how many times can x fit in negative 2x? It's just minus 2 times. So that means that I won't be able to get anything out of this. So because negative 2x minus 2, I certainly do get a remainder once again. That is not a 0. It's negative 3. So remainder is not 0, therefore it's not a root. Okay. All right, so here, what we're going to do is now we're going to take a look at the homework questions from yesterday. All right, and so what you're going to do here is you're going to do synthetic division to solve and answer the following question. Is the divisor a factor of a polynomial? First of all, let's take a look at the numbers. This becomes 1, negative 8. Ooh, first do this. This becomes 1, 1, negative 8, 10, 2, and 4. And so I'm going to use synthetic division with a 2, bring down the 1, multiply, and keep on adding them. And, oh, I'm sorry, that's not a 0. Keep on making that mistake. And so the remainder is 16. So what does that mean for us? Well, that means simply that it's not going to work out. That it's not going to be something where you can look for where this is going to be a factor. So you're going to say, no, it is not a factor. And so this is pretty much what you're going to be doing to every single one of these problems, where you just have to simply take a look at the factors and then just divide accordingly. Just give me 1 second, and then I'm just going to continue the video just a little bit afterwards. Okay, so for the next question, all right, let's continue on from this. All right, so this one here, I want to do 2v minus 3. So if you solve for the 0, that would be 3 over 2. 3 over 2, synthetic division with 4, 6, negative 8, and negative 12. Bring on the 4. If you multiply the fraction with integers, yes, I know that's not really convenient for us, but we still have to do it anyways. That's 6, and that's 12, and that's 18, that's 10, and that's 15, and that's 3. Unfortunately, that's no, that is not a factor. Okay, factor the following polynomials completely. One of the factors is given. Find all the zeros of the function. Now, I believe what I told you yesterday was that I made a small mistake here because once you find out that this is a factor, it's a 3, but you use synthetic division. 1, negative 4, 25. Bring down the 1, 3, 2, 6, negative 8, and that becomes negative 24. So find all the zeros of the function. Well, this cannot happen because this is not a positive 24. So if you change it to a positive 24, well then that certainly works because this is x plus 4 and that's x minus 2. So my completely factors would be x minus 3, x plus 4, and x minus 2. So sorry about that typo. This should have been the correct answer. Well, obviously, if you get a remainder of 1 for this, you cannot solve this any bit further. Okay, so correct answer is technically supposed to be that. All right, so now the homework questions are done, and I want to show you guys what you guys need to be working on for today. I want to show you guys an example of what are the zeros of the function. Okay, so if I give you an equation like this and I tell you that f of 6 is equal to 0, well that means that one of the zeros is at 6 comma 0. And I want you to solve for the other zeros, plural, because we have total possible number of zeros to be 3. And now, so I'm going to use synthetic division once again because I hope the synthetic division is coming to be a lot easier than long division. Bring on the 1, 6, 3, 18, that's 2, 12, 0. So I get x squared plus 3x plus 2 using the coefficients provided for me there. And then you're going to do x plus 2 times x plus 1. Just factoring skills should come out easily now. So what are my other zeros? Well, the other zeros are at x equals negative 2 and x equals at negative 1. This is the type of solution that I want you to be able to tell me for your exit ticket, which I'm going to present for you now. The exit ticket here is I want you to solve for this using synthetic division. And then I want you to tell me the other zeros of the function. Just like the one I have done before. Okay, so make sure you type that in the chat on the Zoom so that I know. It's kind of a good way for me to take attendance as well as if you are paying attention or not. That's going to be going to your grade as a participation grade. It's a kind of like a homework grade slash. So please make sure you finish that. Besides that, no work from me. Just make sure you get the synthetic and long division down. And I'll see you guys next week, hopefully. Have a wonderful Thanksgiving weekend.